I wanted to mention another perturbation that could impact the ability of cancer patients to have the appropriate amount of memory cells circulating. The importance of having the memory cells is really because we're thinking about this in the context of the primary tumor cell has been eliminated, and there probably are dormant cells that have metastasized to other locations or single cells that can even be left at the primary location. If those cells are then stimulated to proliferate and expand, we would want the memory cells that are circulating in the body that recognize those tumor antigens to rapidly expand and eliminate those tumor cells that are left over before they can become a large tumor mass again and affect the biology of that organ. So today we just talked about the fact that it could be an imbalance in those T central memory cells versus those T effector memory cells. And again, we're thinking about the central memory as being the ones that are going to home preferentially to the lymph nodes. And in the lymph nodes, we know that that's where lots of good antigen presenting cells are, and helper cells and all the other accessory cells that would help maximize T cell response to tumor antigens. And we briefly sort of mentioned the fact that besides that, we also had these inhibitory pathways, which we'll talk about PDL1, we'll talk about CTLA4 in the next lecture. And we also mentioned the fact that there's this other actual cell subset that can prevent the activity of CD8 T cells. But there's, in addition to that, the reality is that if there's any change in the steps that are required to generate memory, those also can result in less than maximum memory circulating. And so Usman did a good job at telling you the 3 phases to develop memory. The first phase being expansion. That's just the clonal expansion that we've talked about previously, when a naive cell first encounters antigen. And then after that, after the T cells have done their job and have been effector cells, we go through this period of contraction where the majority of the T cells are eliminated by apoptosis, and what is left over are the memory cells, and that's really that third phase of memory. Changes in any of those stages can impact whether or not we have the appropriate amount of memory T cells that are remaining and circulating in that patient, and that's really kind of indicated here by that dotted line, basically suggesting that there's some level of memory that needs to be circulating to be able to optimally respond to tumor cells that should recur and start to proliferate again. And if we have a number of memory cells that are below that threshold, then you would not have protection, or the protection would not be robust enough to prevent an advanced recurrence of that cancer. So the first one that's sort of shown here is the fact that you can have just not a good enough expansion. And so here we would have the expansion that we want, and we see that in this tumor-bearing person, the clonal expansion just does not get up to the same level of expansion. You don't get up to the same numbers. That means that when you go through this contraction phase of losing 90% of the cells, you're going to end up with less in number than you would if you had gone up to that preferred maximum expansion number. So if you didn't start out with enough T cells, or they weren't stimulated optimally, you would end up having this less robust expansion, and then when they drop down, they would fall below that line. The second way that that could happen is that you could have just fine expansion. So the first phase goes off fine without a hitch, and you have nice expansion, clonal expansion, but for some reason that contraction phase where 90% of those cells die happens too robustly or too much, and so maybe you're getting 98 or 99% of those cells that are now dying, and again that drops it below this threshold of memory, and those would not be sufficient to eliminate the tumor. The third way that it can happen is simply that expansion happens fine, contraction happens as it should, you have that 90%, but then this third phase of memory maintenance doesn't occur, and that can be because we don't have proper responses to the homeostatic proliferative cytokines like IL-15 and IL-7 for CD8. It could be because the receptor's not there. It could be because the cytokines are getting utilized and used up by some other immune cells, and so you would just not have maintenance of that memory pool, and so over time it would fall and eventually drop below that required a level for protection. This was a paper that I also put up in my slides of ULearn that just came out this year. And really I just mention it because it is an immunotherapy that's ongoing. And they do mention, of course, here that, wow, we're impressed that we have a persistent increase in specific memory cells. But then the very next line down here says, unfortunately, it wasn't associated with a significant increase in disease-free or overall survival, which is what we're going for. In this paper, they seem to think that it was because of the antigen specificity of the memory cells that were there. So the ones that we wanted were gone, Maybe they were preferentially lost somehow in this contraction phase, or maybe they just were the ones that weren't maintained because of what they were specific for. And then also the inability of those anti-tumor immune cells to actually respond to melanoma cells. So they were there, they were present, they were memory cells, but they weren't actually able to kill. So they could have been exhausted, as Usman mentioned, or they could just not be expressing the proper amounts of effector molecules at that time. So again, lots of thought currently ongoing about ways to make memory T cells persist, but also to make those memory T cells of the proper quality.